Good morning, ladies and gentlemen. If you can take your seats, please. And just to clarify, because it's an English expression, when we say take your seats, we mean sit down. Because in one of the earlier sessions, some people started to take the seats out of the room. And again, just to point out that we're in a split stream at the moment. So this session is focusing on finished vehicle logistics. If you're interested in the service parts, they're in the other room across on the other side of the exhibition area. But in this one, we'll be looking at connected finished vehicle distribution. You could see in the session beforehand, before the coffee break, how important that is, the difference that the connected car or connectivity is going to make to our whole lives, and how it's going to affect the automotive industry, how it's going to affect logistics. But perhaps one of the areas that it can really have even more of an impact on is actually the finished vehicle logistics distribution. Perhaps I should have started off by saying some people have only just arrived for the second day, so I better introduce myself. My name's Yiakoumi, and I'm the future Prime Minister of the United Kingdom. Yeah, no, we're not going to do a vote in this room. I know what you finished vehicle logistics people are like. You're far too honest with me. So connected finished vehicle distribution is something that's going to, I hope, be something that affects this industry, this sector particularly. So I'd like to then hand over immediately to the panel. We're already running, because of the overrun in the last session, let's try and keep this session lean and mean. We've again allocated a little bit more time so that we'll be eating into the lunch break a little bit, because we don't want to cut short the presentations and we want to have the Q&A at the end. So let's go straight to the first speaker. I'd like to welcome to the podium Hervé and Moulin, Methods and Operations Performance for Alliance Logistics Europe, Renault Nissan. Thank you, Hervé.
Right, so thank you for staying with us. I hope we'll make that interesting. All right, so a few weeks ago, one of our managers was confronting a very difficult logistics problem. And he was dreaming of how new technologies could help him out in the future. So he sighed and he told me, oh, really, I wish teleportation would exist, really. And so I told him immediately, don't say that. We would all lose our jobs if teleportation would exist. So that was not a good example of how new technologies can improve the logistics business. But fortunately, there are more technologies that are readily usable and that offer better business prospects. The telematics capabilities of the new vehicles, for instance, they offer very good prospects for finished vehicle logistics because they will give us access to such data as vehicle location on the transport flow, battery voltage, fuel level. This will prevent loss of time and resources. And also, vehicles will be able to receive instructions from outside, remote instructions such as lights flashing, door locking, things like that, that will be real of good use in the finished vehicle process. But in order to take full advantage of these new capabilities, we must think of a standardization process. The first thing we must look at is the extended vehicle concept, as defined by ISO, ACEA, or the European Committee for Normalization, the CEN. it's important to understand in that case that a vehicle is no longer limited by its physical boundaries, the black one here. This could still function when the vehicle was deaf and mute, and when it was only a pure object to be transported. Now that it has communication capabilities, they must also be standardized. Just like the height of the vehicle or its fuel have been standardized, now we need to standardize the communication. So our project amounts to create a new use case in the blue section of the diagram here, namely the use of telematics in finished vehicle logistics. You can see here that there are other sections, such as the vehicles speaking to one another. But here we are dealing with the exchange, the web service interface with our logistics suppliers. So it's important also to mention that in that case, the communication between the vehicle and the OEM himself and the cloud platform of the OEM will not have to be standardized. It could still be a pure OEM problem. But what we need to standardize is the communication between the extended vehicle, between the cloud platform of the OEM and the data management system of the suppliers. This standardization becomes all the more necessary since we have OEMs that are who are cross-manufacturing vehicles, and logistics providers that have a large number of different brands on the same compound. So right from the start, I take the case of the factories that produce different brands. If we don't have standardization of communications between the vehicles and the logistics providers, we will have problems handling our vehicles and taking full advantage of telematics if we have different standards in communication with the logistics provider. So this standardization will encompass which data will be issued from the vehicles, which orders can be sent to the vehicle and how, and also, of course, everything regarding the pure data exchange format and process. For those who have heard Mark Adriansen's yesterday, he was advocating this standardization for these very reasons, for the port of Zeebrugge. So in order to make this standardization possible, we decided to create a working group as part of the OEM's cooperation with ECG, the Association for European Vehicle Logistics. And at this stage, I would like to thank the teams of Automotive Logistics, particularly Louis Yiakoumi, Christopher Ludwig, and Nimish Ladwa, because this decision and everything that followed began here in the previous Automotive Logistics Conference in 2016. We had a presentation by Michael Gorney from Opel, who is here with us today. And after his presentation, we met and we decided to work on common standards regarding telematics. And after some time of bilateral discussions, we made contact with ECG. And there was the first meeting of ECG Digitalization Working Group on this subject on May the 5th in 2016 at Jaguar Land Rover, with the participation of several logistics suppliers and several OEMs. And in this meeting, the main building blocks for standardization were outlined, and the roadmap was created to associate other LSPs and other OEMs. And shortly afterwards, 12 OEMs were around the table with many LSPs and also some software providers. And it was decided to go on with the standardization. There was an LSP meeting also in January of this year to list the most interesting use cases. And these use cases were confirmed on the OEM side during the latest ECG digitization working group on April the 28th. So there were participants also from the EU DG Move, from ACEA, the CEN, Audet, and Gallia. And we all decided to officialize this standardization in official standards that will become first an Audet specification, then a CEN standard, and we may go on afterwards with an ISO standard, which will make it even more than European. So the next steps of the project, currently in progress, are the official endorsement of the project by ACEA and CEN and Audet, and then the expert group, for which we are collecting the support of the participants. The expert group will start working to define the standards. Our objective is to provide detailed specifications by March 2018. So there are a number of challenges ahead in this project. Is that the first one is that some OEMs haven't joined yet, but more and more are doing so, and we've already had contacts with some that need to join in. So I would like to urge the OEMs in the audience, if they haven't already done so, to come to see me afterwards and make sure they are in the right move and join in if it's not already the case. There's also another issue. It's the technology development is happening faster than the normalization. So many OEMs are already working on their telematics control units, and they are creating the specifications for their own use, and they can't wait for the proper standardization to work. If this standardization, as many CEN standards, takes an average of 3 years. So, as I said before, our objective is first to have the specifications drawn by the expert group with Audet by March 2018. And thanks to these specifications, we hope that all the OEMs will have a good visibility for their own developments afterwards. So there were other questions that were asked to the speakers today about in the program about digitization and what we could do in finished vehicle logistics. The next one was which technologies would be the most disruptive. And the more we work on it in our company and with our partners, the more we think that there isn't one technology that will do the whole trick. In fact, we have a very large supply chain that encompasses large compounds run by very experienced and large companies, large logistic companies. We have smaller ones. We have ports. We have the truck driver alone with his truck. We have the dealers. We have the PDI workshops, PDI companies, the coach builders. So there's a lot of different situations in terms of use of technologies, a wide range of situations, and our vehicles must go through all these steps before reaching the dealership and the final customer. So we really think the key word is adaptability, and that what we are doing must enable us to come out of every situation and give the maximum information and maximum opportunities during all the transport chain, whatever the step we are in. If I take RFID, for instance, it's very well adapted for when you have a big compound and large flows, but you will not be able to ask every dealer to get equipped with that. So it's through a mix of technologies and a mix of building blocks such as the e-gate, the ECMR, and the digitization of transport documents, connected vehicles, use of smartphones and tablets, and autonomous vehicles. All these are building blocks to build future supply chain. And we must combine all this to reach the vision we want to have for the future logistics. No unique technology will solve all the problems. Another question of this panel was how to balance the cost of innovation with return on investment. And it's indeed, I think, a problem for every company. In my experience, I personally believe our managers must consider things differently in these times of deep technological revolution. I very much liked the presentation we have shortly before about the smart factory. It's approximately the same approach, I think. Many ideas integrated into one concept. That's what I would like all our managers to do when they think of the future supply chain. I would compare it to a jigsaw puzzle. And as you see, I took a famous example from my country. So let's say you have a 1,000 pieces puzzle, and you show it to your managers, and they agree that this is the final picture we want, definitely. This is the logistics of the future, complete vision. But the problem is that currently they ask us to justify every one of the 1,000 pieces to build that. And if some don't seem as interesting as others, such as the black one here, you see that the picture wouldn't be the same without this piece. But indeed, it's black. It's less interesting than the smile. But you cannot keep the smile only, or else the picture would not mean anything. So my point here is that we must decide. We must have a clear vision of what we want to do for the logistics of the future, the future compound, the future supply chain, which parts it should include, and then have our managers decide of the whole picture, and then go for it. Even if some parts are less interesting than others, if everything is coherent, then we should go for the whole thing. If we leap into the future, we shouldn't keep a foot in the past. And that will be my conclusion. Thank you very much.
Thank you, Hervé. A good start to the session, sharing some of the ideas and the progress that's being made to improve the communication. And typical French, finishing off with a work of art and also an advertisement for Paris and the Louvre. Next up, we want to hear for someone who's always comes to our conferences with great new ideas and different ways of thinking. I'd like to welcome to the podium Manuel Medina, finished vehicle distribution planning for SEAT. Thank you. It's on the, yeah, thank you, Manuel.
No. When Nimish from the team from Louis phoned me to talk on data for distribution, I accepted. But my real thing was that I would like to talk on logistics. But at the end, we are logistics, or not? Yes or not? Please? Please? I would like to fill in an assembly of logistics. Tell yes, so hard, please.
Yes. Yes, we can. I'm proud of it.
And logistics, we have challenges. My story starts 2 years before, not some days or some weeks. My story starts when my big boss asked me to reduce 30% the casting compound. Not 1%, 2%, 3%, 30%. Why? We analyzed that our focus was the cost reduction. And where is the cost in logistics? Mainly in transport. But we use some resources in factory without any recognized cost in terms of surface, in terms of management, in terms of human resources, but they exist. And the reduction of this space can help a lot in the factory to improve layout, to improve production. And also, if we think in logistics, when we move the car from the point A to the point B, getting the car closer to the dealer or to the client, we can tell that we are adding value to the car. But when the car is remaining a compound, when the car is doing nothing, is consuming resources, then we don't change our focus from the cost to the compound, but we add to other focus in our targets to improve it. I told you on 2 years before, perhaps in a year and a half, we achieve a reduction of the casting compound, implying the corresponding surface on 35%. Changing our mind, changing our procedures, looking for a better control, looking for a better analysis of the data, of our performance, of the deep data, not in terms IT, but in terms that the data are not visible, and we improve it. But the key word from my big boss is we have never enough. And the challenge was, could we continue improving? And I told him, why not? Why not? Because in the time we was working to reduce this 34%, it was a lot of ideas that remains not feasible because need developments, need money. But we accepted the challenge. And with these ideas, we are looking for this. You can think it's impossible, could be. But only thinking the impossible, you can achieve a relative approach to that. And this is logistics. What is our concept? We call to this concept virtual compound. 4.0 is right here because if one adds 4.0, it's fantastic to open doors. But at the end, I believe in a concept that it calls virtual compound. Many of us, mainly OEM, we are working, in fact, when the car is manufactured. That implies a long process of documentation, information to the supplier, to the LSP, and, of course, arriving, receiving the car, extending delivery documents, and at the end, the deliver out of the factory. The idea is, as wrote, to move the physical compound towards a virtual compound. That says, start the work with our suppliers, start and close the compromises with our suppliers before the car is manufactured. Okay, main constraint, IT developments. That is why this, my speech is included in the frame of the current one. What is and what is not? I think it's important to clarify this point because it has been some discussions inside my company in order with we achieve an improvement of the compound management. So, okay, compound management is one thing, and virtual compound is different. To improve the compound management, okay, I need to improve the algorithms that my IT systems calculate to place the car in compounds in order to frequency, to reliability of the supplier, or the volume of the units, or also the mean of transport it needs. This is a yard improvement, improve the yard management. Virtual compound is a more holistic concept. Then contains all the activities related to the delivery and to improve the coordination between factory and transport company, as if this point is the same point that pass from painting workshop to the assembly, or the connection between a just-in-time supplier on the line. Basis, prediction. Okay, we have analyzed it relatively deep, the data in our factory, and we think that we can achieve a 90% of reliability in terms of shift when one car will be produced. The idea is to achieve this reliability 5 days before car will be finished. Of course, the language of the transport company is not our language. We are talking on chassis, but transport company talk on cars. If there are 10 cars to Austria, it's the same if the VIN number at the end. The most important thing is that this truck should load 10 units. That if we close the vinculation between chassis number and load, we can achieve an improvement of the reliability. And we calculated our challenge is 100%, also at shift level. What comes later? Communications. All that I explained to you is fantastic if we have at the end, a nice Excel sheet with a lot of data, what we do? We need to do a lot of handwork, getting the data, informing to the supplier A, B, C, D. And in comparison as today, if we have this work once by week, I cannot imagine if we should to do this work 5 days before, 4 days before. See, this is a lot of multiplication of the work if we went to trade the data, the previous data in manual way. Then we need a systems of communications. And we need a system that allocates the cars to the suppliers in automatical way. At the end of the day, and I think you will agree, that the human resources are not, should not to be used to do routine and systematic tasks that today can be done by systems. The big importance of the systems in our times is that allow to increase the speed of activities. And then, okay, we can send all the information and our clients can process all the data. And the focus of the people who is working in our teams should be to trade the incidents and be dedicated to add value activities. That is the reason, that are the two reasons to automatize the communication and the allocations. But later on, we think that we need to control how it's running. And that is, we have defined the systems that we call GOLRs. We are thinking in the opposite way than usual, not in control the time from the factory to the dealer. This is the usual task our boss requiring for us continuously. Adjust the delivery times. And then to control the truck and control the car when leaves the factory until arrives to the dealer. Here our focus is just the opposite. To control the empty truck coming to our factory to pick up the cars in order to synchronize as much as possible when the load is completed and the car and the truck is coming. As latest, this slide, you can see how all these systems, how all these modules are integrated. The system of predictability covers -5 days and -2 days. Translations translate this information to the LSP language and inform -5 days forecast, -2 days forecast. Our requirement will be that the -2 days forecast is a compromise from both sides. And of course, if the first supplier cannot fulfill the requirement, okay, automatically the systems go to the third, and later automatically the systems go, we imagine, not only manual actions, but also IT marketplace for these loads without company, see, that cannot to be transported. And we have defined it also, I don't want to enter in the detail, I think it's not for your interest in this forum, 4 levels of alerts. Of course, the cars, all is okay. The cars, we don't have supplier or have any other relevant problem that disturb the coordination between supplier and manufacturing, and some two intermediate ones, depending, that cover different cases. This is my presentation. First sheet has been direct to the challenge without any kind of previous presentation. And this is my last one, that I would like to remain in the screen in the time I said thank you for your attention, and I am open to any question you have in the time of questions.
Thank you very much. Thank you very much, Manuel. And as I said before, always trying to challenge us and trying to challenge himself to come up with different ideas. So, virtual logistics, interesting concept. And next up to hear from a logistics service provider, albeit an IT logistics service provider, I'd like to welcome to the podium Paul Nurse, the CEO of ProAct. Thank you, Paul.
Good morning. I'd like to talk a little bit today about connected vehicles, but obviously specifically in the context of supply chain, and a little bit about what technologies are available to us, what are the potential benefits, what are the potential challenges that we have, and what might be the short-term reality of how we can leverage vehicle telematics or connected vehicles, as it's called today. I don't want to go too far into the future. I want to stick with really what we can achieve in the short to medium term. So, to begin with, maybe let's go back to basics and look at what technologies we have available to us from within the vehicles themselves. Connected vehicles, we can really just call telematics. That's essentially what it is. It's been around for many, many years. Many of you today will have telematics within your trucks, giving you vehicle data, distance, speed, temperature levels, fuel levels. So there's nothing new about telematics. It's been around for the last 20 years probably. And in the extreme cases, the extreme applications, you'll see telematics used in Formula One cars for monitoring just about every aspect of the vehicle. And even in two-way communications where they can actually change the setup of the vehicle while it's driving, while it's on the track. So we're dealing with a fairly tried and tested technology, a technology whereby we've transmitted the data back over cellular communications. Again, in the early days, we were dealing with GPRS, and obviously in more recent years, we're into 3, 4, and soon to be 5G. I guess the only difference is, up to now, that's been done in a relatively low volume environment. So we're dealing with a few hundred vehicles as opposed to in the connected vehicle world where we're dealing with hundreds of thousands or even more vehicles. So we can take this technology and we can start to apply that to connected vehicles itself. In doing so, there are three main things we have to consider. We have to consider, firstly, the communications. How do we get information from the vehicles? Secondly, what devices do we need to both read and consume that information, and also what sensors do we need to generate relevant information? Again, I'm talking about information that's relevant to the supply chain, to logistics. And finally, ultimately, we could be generating an awful lot of data, call it big data if you want. But ultimately, we need systems at the back end then that can consume all this data and make sense of it. So there's three main components to being able to use telematics. If we start with the communication side of things, what do we have? Well, firstly, we have cellular, and that's been used, obviously, for many years to transmit telematics back from things like vehicles or whatever application we've already used. It has some other uses. Obviously, we can connect directly to the internet, so we can access the internet directly. We can use it to triangulate the position of vehicles. So if we don't have other positioning mechanisms, we can use cellular to do that. But we have to take into account that there are different coverages in different areas, in different regions. Some areas will have 5G, some areas will still be struggling with 3G. So if we're going to use that to get information back from vehicles, and we're going to do that at a global level, we need to consider that in many cases we might hit temporary or even complete black spots in the supply chain where we cannot get information back from our vehicles, possibly for days or even longer. So we have to consider that it is not a be-all and end-all, but it is the primary mechanism for getting data back. We also have to consider that communications costs. And certainly, when we're dealing with a few hundred trucks, it's one cost. When we're dealing with 1 million vehicles, it's a completely different cost. And when we go out internationally and we start to effectively, we're roaming in terms of telecommunications costs, then the costs go even higher. So all of those costs times 1 million vehicles, we have to consider very carefully how much data we can realistically transmit back from the vehicle itself. The other technologies then we have available to us then are short to medium term range technologies. And they are things like Bluetooth, Wi-Fi, NFC, near field communications. These are all common technologies these days, and we certainly believe these are the technologies we have to leverage for the future. So all of these things are proven. I mean, we have Bluetooth. Well, we have Bluetooth in our cars, obviously. We have Bluetooth in our phones. We have Bluetooth in headphones, fridges. Just about everything these days has Bluetooth in it. And the same for Wi-Fi. We use NFC, or many of us use NFC every day when we go and touch a card and process a transaction just with contactless technology. We're using NFC. So these are things that are prevalent, they're common, they're used everywhere. And consequently, the cost of these technologies is going to come down at a very fast rate over the next few years. So being able to use these and make good use of those is one of the key elements going forward. Obviously, the cost makes it more and more viable, and we project that these things will fall far below some of the costs of maybe existing technologies like RFID, and they will get to a point where these things are, in terms of tags and such like, they will become disposable technologies in the not too distant future. The other consideration for these is that some of these technologies are more power hungry than others. One of the good things about Bluetooth specifically is that there are low energy derivatives of these things, BLE, low energy Bluetooth. Tags, Bluetooth devices, they can have standalone lives of up to 5 years. So if we consider putting these things into vehicles, we don't necessarily have to integrate these things into the electrics of the vehicle. They can be standalone, they can not interfere with anything, and we can still use these things for a number of years if that's required in the supply chain. And what we predict we'll see is that these things will rapidly start to replace some of the more traditional technologies, things like I mentioned RFID, because again, most devices these days, whether it's a phone or a tablet or anything else, they can read these types of technologies. They're all universal. So again, it's more inclusive, whereas, for example, RFID only is available to, let's say, the particular yard that it's deployed in or a particular facility that it's deployed in. Once you leave that facility, RFID then is often useless to the next person in the chain. So we've got to be using and leveraging more and more of these technologies. Clearly, a part of collecting data is positioning. Whilst we can, as I've said, do some triangulation through cellular, obviously the primary mechanism is GPS. To be able to derive a GPS position, you've got to have technology in the vehicle. Obviously, the tags and things don't do anything on their own. The vehicle has to interpret the different signals and then determine its own position. So something, be it the vehicle navigation system itself or something around the vehicle connected to the vehicle or the devices that are reading the vehicle, need to position it. But with that, we can get fairly good accuracy, around about sort of 10 meters, possibly good enough to locate the vehicle in a small area, but maybe not quite good enough to locate it to bay level. But clearly, there are lots and lots of uses in terms of taking that GPS data and basically being able to interpret it. And what we need for that is to be able to define what we term geofences, so areas that the VINs or the vehicles can exist in, should be in, and areas that they shouldn't be in, and be able to alert when those GPS messages indicate that vehicle moving from one zone, one geofence to another. But obviously, it's a key part of being able to track the vehicle or anything else associated with the vehicle, trucks and everything else. So those are kind of the main technologies we have available to us today. From a logistics provider point of view, because that's what this is about, it's about logistics, what do we need? One of the most critical things we believe that we need is to put some kind of universal identification mechanism into vehicles. So today, some people will be scanning vehicles, scanning barcodes, some people will attach RFID tags. So there's a myriad of ways of actually identifying that vehicle when it hits your facility or your transport operation or whatever else. We think we need something that's more universal, more inclusive than that. And all those three technologies we've talked about, the Wi-Fi, the Bluetooth, and NFC, they're all candidates for that. We, as it happens, are pushing Bluetooth because of three main things. Firstly, the flexibility. Not only can we track with Bluetooth and publish identities through Bluetooth, but we can connect things into Bluetooth devices. We can even connect Bluetooth into sensors. So there's a lot of potential for the future. Even if we're not using that today, there's a lot of potential for the future. Also, the cost of Bluetooth, again, will be falling rapidly over the next few years. And again, we get some more range out of Bluetooth, so it gives us more opportunities for the future. We can get up to 250 meters, I think, with today's Bluetooth. And finally, anybody can read it. Anybody in this room with a phone and an application or an iPad or a tablet or a scanner, you can read Bluetooth. And that means that it's not then specific to one person in the supply chain. Once we've identified the vehicle, then we can start to make use potentially of the telematics within that vehicle. So if we can get back then information relating to things like battery life, tire pressures, all the things that you see there, we can start to make improvements in terms of maintenance, in terms of dwell time. So we can preempt the fact that we're going to go to a vehicle and turn the key and nothing happens. So if we can do that, and if we can get alert warnings on the vehicles to say this battery is low in this particular VIN, then we can go and deal with that before it becomes a problem. In doing so then, we can minimize dwell times, we can increase throughput, and then we can decrease the amount of maintenance, not only because we're preempting the problem, but also because we don't necessarily have to charge every VIN every 30 days because we think we have to. We can just address specifically the VINs that have a particular battery issue. That's a problem today, but if you think about in the next 5 years' time where a lot more or higher percentage of the vehicles are going to be electric, and the battery is not now needed just to start the vehicle, but actually to move the vehicle, that will become more and more an issue. Clearly, having GPS information, diagnostics, all the other things there, all give us opportunities to determine whether the vehicle is in the right place, to monitor the number of kilometers that are on the vehicle, on the odometer, to determine whether we've moved it too far, we've driven it too many miles. All of these things we can use to help basically improve the throughput and improve the quality of the supply chain. So there are, of course, a number of challenges. Firstly, there are the technology challenges. And the first one I mentioned there is we've never really done this in a volume environment. We've done this with hundreds of vehicles. Now we're talking about 1 million plus vehicles or millions of vehicles overall. There are always power consumption concerns. Everybody says we don't want to drain the battery. But there are, as I mentioned, there are solutions to that today. They exist technically today. Communications costs, again, could be a challenge. We have to determine how much data we collect, how frequently we collect that data, how that data gets to us. I mentioned communication reliability. We have to accept that at some points we might enter sort of a complete black hole of information and we don't see anything for a period of time. We've already talked a little bit about messaging and standards. If we're going to do this, we need ideally to have some kind of standards where we know that any brand of vehicle that comes through our facility, our yard, our transport operation, we can accept information in a standardized way. So again, it's another aspect of the technology challenges that we've already talked about this morning. And in all of these things, there are security aspects. How do we ensure the security of being able of protecting the data that is coming from that vehicle, both in the supply chain and also after that supply chain has moved, has finished, sorry. Probably more of the issue is not technology, because we can do a lot of things with technology. We can solve most problems with technology. The issues or the challenges are probably going to be more on on the political end. I heard a lot of interesting conversations this morning about connected vehicles, about how it can change the consumer experience, how we can connect it to media networks and all those kind of things. So it looks like it's a great future for consumers of vehicles. I don't think I heard probably a mention today about how telematics, how connected vehicles can help the supply chain. And as Manuel pointed out, this is about logistics, and as the sign points out, it is about logistics. So really, one of the challenges we have, my colleagues aside here, is that we have to convince OEMs generally that there is some value in sharing their data with service providers. Okay, so that's one of the key things. We have to have the buy-in of the OEMs in doing this. Once we've done that, then we have to determine how we access those systems, whether they're going to give us direct access to the vehicles or whether it's going to come through some indirect routing. We need to obviously take into account, again, the security aspects, privacy, and of course, how often will we get this data? Who will provide it? Will the OEM give it to us? Do we have to go and ask the OEM for that data? They're all issues that we have to address. So the reality, probably in the short term, is that we won't be able to talk directly as service providers. We won't be able to talk directly to the vehicles. We'll have to talk to the OEMs and get that data via the OEMs. The OEMs will manage the data. The data will go back to the OEM systems, and then through some mechanism, we will have to either accept alerts or query information from those OEM systems. In doing so, and then having to do that, it makes the LSP systems critical, because those are the systems now that have to process all that data, that myriad of data that's now coming at them, and actually make some sense of it and determine, leverage that information either to manage maintenance functions or to somehow streamline the supply chain. So the LSP system, the service provider systems are key because they've got to do all of these things here. They've got to accept the data, they've got to process it, they've got to interpret it, they've got to determine the consequence of that data, and then they've got to initiate reciprocal actions. There's a lot of things it's got to do, and then it's got to determine what the impact of that is within the overall supply chain itself. Okay? So all of these things are part of what the service provider needs to basically usefully use that data. And basically then use all the different feeds, whether it's coming from telematics, whether it's coming from EDI, whether it's coming from devices. So whatever channel we're getting that information from, then to be able to represent it in the overall supply chain and ultimately influence, at the very end there, the promised date to the dealer. So finally, just to summarize a few of the things we've talked about, really, as yet, we don't know what we're going to get from the OEMs. We have our groups that we're working on as I'm part of the digitization group. We know there are a number of OEMs that have already bought into this, and hence we're looking at standards and ways of dealing with this data. The OEMs, as I've said, have to, in a wider sense, have to recognize that there is some value in providing this data at the end of the day. And I think that comes back to us as service providers to firstly decide what it is we want in terms of telematics data, what is useful to us, and demonstrate how we can leverage it, and also then quantify that in terms of savings, in terms of dwell time, in terms of cost savings, in terms of efficiencies. So one of the things we haven't done at this point really is to quantify that into any useful figure, because at the end of the day, OEMs will only provide us that data if there is an advantage to doing so. In addition to having sort of regional and European standards, we need to consider the wider global standards. We need to consider, obviously, the US market, Asia market, and what might be happening there in terms of vehicles and telematics and the information that they may or may not provide to us in terms of the supply chain. It's probably more disruptive to try and handle half of your cars with telematic data and the other half without. You want to do an all or nothing, really, to make most efficiencies as a provider. And the final thing really that's sort of obviously close to our hearts as an IT provider are the systems at the back end. We will, once these floodgates start to open, there will be a huge amount of data that flows at us. We've got to be able to usefully use that in terms of IT. We've got to be able to consume that. And as I said before, we've got to be able to interpret what it really means and then automatically initiate reciprocal action to deal with that, to change the supply chain, but to respond to those events in some way. So really, the message is that the floodgates will open. How quickly, we're not sure. But as providers, we need to be ready for that today. Thank you.
Thank you. Again, I'll do the Q&A from here. As a future Prime Minister, I think I deserve these kind of luxuries. Another very interesting presentation there that brought it even more down to the logistics level and also, very importantly, gave the perspective from the LSP, not just from the car maker. So this is the Q&A and comment part of the conference. You know, usual rules, please raise your hand, wait for the microphone, state your name and your company name clearly, and then, as I said, you know, ask your question, make your comment. A question from my side to start off is, I think we kind of glossed over it a little bit. Is that security aspect? You know, I think we hear about some hacks. We had a terrible one in the UK that affected the NHS, the National Health Service, but I'm sure we don't hear. You know, I'd be surprised if we hear 1% of the hacks, major hacks that are happening to banks and goodness knows what. So, you know, it's fair enough. You know, I think one of the speakers yesterday said about, you know, the connected fridge. You know, the big security issue there would be, you know, oh no, my Haagen-Dazs has melted. You know, someone hacks into my fridge. But a connected car is a completely different thing. There's a real, you know, danger or potential of danger for that. So we're kind of planning a lot on this connectivity and so on. Are we ignoring, dismissing a very important factor, or is that, and are we planning to do something that might not be feasible when the reality kicks in? You touched upon it with the political aspects and so on. So how important is that, or are we dismissing it easily, or is it something that's in everyone's minds, but there's nothing we can do about it? That's at a higher level than us.
I mean, we've talked about the initial telematics, the short-term realities, and that's getting fuel levels and things like that, and possibly that's not so sensitive. In the future, as and when we eventually do arrive at you know, autonomous vehicles and the potential to want to get the vehicle to move itself from one bay to another or load itself onto a truck or whatever eventualities that do happen, then clearly security is a huge issue. Because if we as a service provider can move a vehicle from A to B, then anybody else can potentially move that vehicle from A to B. And that's going to be a wider, probably more an after-sales consumer end issue in terms of security. But yeah, as we're able to interact more with the vehicle and give the vehicle more and more instructions, then clearly security becomes a huge issue.
But I'm not even just talking about crashing the car. I'm talking about, right, we've disabled your system unless you pay us whatever it is or something like that. That, you know, that's my kind of concern.
Clearly, this is a subject that is that far exceeds the logistics perspective, because the advantage for us OEMs about telematics is that it is used by other parts of the company, and it has a wide range of uses that enable us to share the cost of the devices and the technology with other parts of the company and other uses. So all these security aspects are taken very seriously by our companies, especially regarding the use by the final customer, privacy and security. So these parts of the companies, the commercial parts, etc., they are driving these aspects, and they are under constant supervision of the consumer and political authorities. So they will pay particular attention to that, and we logistics we will inherit these rules and specifications.
How much is the telematics already being used to help you in logistics? Because there is telematics in cars already, so how much of that is already being used, even at a basic level in the car makers? What access have you got to this kind of information?
It really depends on the car maker. Some of us are more advanced than others, but generally we are all confronting the same problems, same questions, and we have, as far as I know, we have a consensus of how it should be used in logistics. The main use cases have been discussed, and the standardization process will also help in defining common uses about that. And those who are behind will catch up. So in the end, I think there will be little difference, even if for a few years, some may be more advanced than others.
Manuel, are you using?
In our case, I didn't do it today, but usually when I introduce a speech and present my company, I tell that my company is one of the smallest company in the sector. No? Despite the companies in our sector are relatively big, in our case we're small. And not only small, for a lot of years we are in red figures. Now, luckily, it's not the situation. Okay, and then we don't think on technology. We think in improve the processes. That means the use of technology, focus it to add value to the processes. And in this sense, but not only in our company, but I think in general, the application of technology was more focused in inbound part. Just-in-time communications with suppliers, coordination between time the pieces are delivered, coordinations pick up, little supermarkets, also visual readings, all these kind of things. Only in the last years, because I think the company management has been conscient the impact in the cost, and not only in the direct cost, but also in the resources used by outbound, we started to apply the technology in the outbound. In terms of this application, RFID, I presented sometimes, and in our house is running from 2014. And now we are focused to use the technology to improve the use of the internal resources surface in our house. Okay, telematics in terms of control of our suppliers and receive information from our suppliers, okay, exist from long. We control the cars until the Incoterm, until at the end of our responsibilities. But this is the thing that for us was a part of the process, and we don't do importance because it's needing. Another thing that with the current technologies we can control better, but in the list of in the wish list, we have first to improve the compound, and that thing, as I told, we have made an activity 2 years long in order to reduce, without improvement of technology, with improvement the processes. But now we are in a phase that we need technology if we can achieve this ideal challenge.
And can you influence the telematics going into the car? Because I'm guessing at the moment what you're doing is they're saying this is what we've got, and you're trying to take something from it to help you in logistics. Are you able to say to the IT or whatever department, engineering department, say, whilst you're considering the telematics that's going into a car, this particular aspect of it would really help us in logistics for cost or efficiency reasons?
Yes or not? Yes and not. Usually, I talk in our case, but I think that I can generalize my assessment. The telematics in the car, the management thinking, the management mind, is to use the telematics in the car to control the delivery at dealer or the delivery at client. The time the car remains in the factory, the time is in transport, the transparency to the client, that the client can see where his car is in each moment, in the assembly chain, in the delivery. No? But we need something more. We need something more than this. Yeah. And this is the challenge we face, how we can apply the telematics, because, and I repeat that at the beginning said, is more focused to the delivery at the client than in the logistics.
I think in our case, the answer to your question is yes, we can have an influence, because as I said before, we are sharing this technology with other parts of the company. And since we are sharing it, we are also asked to provide savings and value added from our side. So if we are, the consequence is that since we are asked to provide benefits from the telematics, we also have the right to ask for what we want. So it goes with it. So in that case, we can have an influence. Although we have to share this influence with the other parts of the company who are, fortunately, we can discuss with them and have consensus.
Are there any questions out there? There's a question right at the back, please.
Good afternoon, everyone. Björn Svenningsson from USSC. I think it's been a lot of informative presentations this morning, a lot of talk. What I'm missing actually is some strategies, some actions for what we as LSPs need to do, are going to do. And that's of course something that we need to do at home. We need to do our homework. But at the same time, I think that in order to get some traction, I think some of the benefits of digitalization, the usage of telematics, whatever all these buzzwords are, I think it needs to be quantified to get some traction. So I was wondering if any of the OEMs have put some numbers on this. What could you save by actively doing something about this? And I think that's really what's needed to get traction, because there's a lot of talk, a lot of information, but we need to move. Time is flying.
It's a good question, because I think to get things done is, if you say, I want this because of this reason, or whatever it is, it's one thing. But if you say, it would be good to have this because it will save us €1 million, there's a completely different reaction.
Yes. I thank for your question. I just told at the beginning of my speech that we start the work to reduce compound space only because our boss analyzed our function in a different way than the previous ones. The previous ones, and finance people, look at the invoice we pay at the end of the month. Transport is a real cost with an invoice at the end of the month. But if I am going to my controller to tell him, if I reduce 1 meter of compound, how much is the spare? He tells me nothing, because we have this space in our books, and we will have this space in our books. Are used by you or not? No. See, I share with you this worry, because it's a barrier to improve a lot of things. I share. In these terms, or in other terms, what we achieve, what we would like to achieve with this project, not only reduce needings of space, also, in case of the ship, it's more difficult to apply, but in case of the trucks, I think that is very clear, to increase the performance from our suppliers for himself. is very different if they have information with a high level of reliability 5 days before that information just at the moment the cars are manufactured. In these terms, and I didn't mention it here, no? But because the focus of the project is, as told, in the space, but there are other benefits that can be shared in the chain.
Hervé, any comments?
Yes, I think Paul Nurse has answered partially your question in his presentation. In his last slides, he said that it was the homework of the logistics providers to help us determine how much, what would be the potential benefits of telematics and such technologies, because we will be driven to do more and to give you this information, we OEMs, if we can demonstrate there are some benefits in our companies. And since most of the benefits will be done in the transport flow, and we will incur the cost of developing these logistics applications in our systems, this needs to be a shared work. We cannot imagine by ourselves the real potential benefits. We need you to help us determine that.
Yeah.
Okay.
I agree with that. I said that in the presentation. I think
Yes.
you have to come at this from two sides. A, what information are the OEMs prepared to give us? So there's that side of it, which we're still not totally clear on. But B, what do we need as service providers? What is going to be useful to us? Is that, in the simplest terms, things like locations, things like battery levels, battery level alerts, and knowing, what having a battery level alert might do for us in terms of saving the number of vehicles that won't start, the amount of time we need to spend on the maintenance, the amount of vehicles that we may not be able to load because they can't start. As a service providers, we should hopefully be able to sort of quantify that side of the argument. But equally, we need to know what data we can get from the OEMs, what frequency. It needs to be timely information. It needs to be relevant. It needs to be usable. So there's two sides to this, really to meet in the middle and decide what is useful. Today, I don't know. We haven't quantified that. You're right. And today, what that figure is, I don't know. Certainly in 5 years' time, and as I say, as we get more towards electric vehicles and different technologies, I think those savings, whatever they are, will be far, far bigger.
Okay, thank you. We will have to cut it short there. I know there's some more questions, but we had to cut it short. And I'll be honest, the main reason is yesterday I missed the creme brulee at the end of the lunch. So to make sure that we give ourselves time to have the 3 courses, I'd like to finish this session now. So thank you very much to the panel for, again, another interesting discussion. After the lunch, the think tanks will be back in this room. Everyone will be back in this room. And there are some think tanks on finished vehicle logistics specifically. So please come back and join the think tanks. And then we have the final session at the end of the conference. We'll have a quick discussion, rounding up some of the things we've discussed today or over the 2 days, things that we've missed out. So please stay for the final session and the final Q&A. And if you liked the session, if you can let us know, by either using the iPads outside or something, or if you want to use the app that we've got, if you can say, whether you like the session, didn't like the session, although I'm sure that won't be the case. But as always, your views are very important to us. So thank you very much. See you back after lunch. Bon appetit. Thank you.